Today we are going to discuss discrete probability distributions. This is your second unit, and first unit basic probability we learned and random variables also we learned. In that particularly we learned what is meant by random experiment, sample space, event and definition of probability, addition theorem, multiplication theorem, and next Bayes theorem, conditional events, conditional probability. And after that we learned random variables. In that different types of random variables we learned. So one is discrete random variable, another one is continuous random variable we learned. So discrete random variables and continuous random variables we learned, right? So in that we learned mean, and next here also we learned mean and variance we learned, that is nothing but sigma square. And here also we learned variance and standard deviation. Along here it is standard deviation, along with that median and next mode. Okay, so all these parameters you people learned in first unit, discrete variables, along with that moments. Okay, next random moments, and finally Chebyshev inequality. All those things we saw that in first unit. Okay, now here itself we are particularly learning discrete probability distributions in second unit and continuous probability distributions in third unit. Okay, so here this one also we got it in your first unit, discrete probability distributions. So discrete probability distribution means what we learned there. So if we are taking different values of x, so like as x1, x2, x3 and so on, xn. So like that you chosen different values for capital X, and capital X representing a random variable. So x represents a random variable which takes the values x1, x2, x3 and so on, xn, and respect to probabilities. So p of x also we calculated, right? P1, or simply we are writing p2, p3 and so on, pn. Or in other words we can say that p of x1, p of x2 and so on, p of xn. Okay, so like that we constructed a probability distribution table. Okay, so that also will say that there we learn, and here we are going to learn finding frequencies. Okay, for the discrete random variables. So for the discrete random variables we are going to calculate frequencies. Okay, so that one we are going to learn. In that different discrete distributions we are going to learn. Okay, so first we'll see that what is meant exactly that. So a theoretical distribution, or in another words we can say that theoretical distributions are probability distributions, both are same. Okay, so you can call it as theoretical distributions, or simply you will say that probability distributions. Okay, so is the frequency distribution. So probability distribution is nothing but simply what we are saying, frequency distribution of a certain event. If you are taking particular event, and that is if you are finding that probability distribution in which frequencies are obtained by mathematical calculations. Well, we will get those frequencies by our calculations. Okay, and next here it is the value of the random variable and the corresponding probabilities are arranged in way that one can suit a mathematical function for the probabilities in terms of the value of the random variable. It means simply what we are saying. Just now we discussed. So the value of the random variables, that is nothing but we are taking as x, and the corresponding probabilities is nothing but simply what we are taking, p of x or p, are arranged in such a way that one can suit a mathematical function for the probabilities in terms of the value of the random variable. So what we are constructing the table x values and respect to probabilities. If we are constructing a suitable function, so what we are here is function. Okay, so that function we are calculating in terms of the values of the random variable. Just next, just in the case of actual frequency distribution, the various statistical measures such as mean, standard deviation, etc. are computed. So also such statistical measures easily calculated in a theoretical distributions, and they give a very close approximation to such statistical measures as calculated from the actual frequency distribution. It means that already in below 10th class level, if people you know that how to calculate mean, standard deviations, variance in your 10th class level. Okay, so by using probability distributions we can also calculate those things. So those things simply we are calling as statistical measures. Okay, and that statistical measurements are nothing but mean, variance, standard deviation, all these things we call as a statistical measurements or central tendencies, we call those things. Okay, and these things easily we can calculate by theoretical distributions or probability distributions. And but the disadvantage here, they give a very close approximation to such statistical measures as calculated from the actual frequency distribution. It means the actual frequencies they will give, we need to find the expected frequencies. That is the thing we are going to learn here. By using these distributions, we can calculate frequencies also, but those frequencies may not accurate. Okay, but approximately we may get those frequencies which is nearer to the exact frequencies. It means like as suppose x we know that, and frequencies also they'll give that. This is we called as the observed frequencies. It means what they give, and we are going to calculate expected frequencies by using these probability distributions. Okay, by using probability distributions we are calculating expected frequencies, and easily we can get it these frequencies comparing to this. Okay, so comparing to this we can easily get these expected frequencies by using probability distributions. But the disadvantage is here, we never get the exact frequencies what they give, we get only approximated frequencies which are nearer to observed frequencies. So what we learned finally, why we are learning this means we can easily calculate frequencies, okay, by probability distributions. Okay, in that we are saying again discrete probability distributions. Okay, of course continuous probability distributions also we have. Okay, next. Here it is, so this way already we said we have two different types of theoretical distributions or probability distributions. One is discrete probability distributions, another one is continuous probability distributions. So in this discrete probability distributions, binomial distribution, Poisson, rectangular, negative, geometric distributions. So these many of distributions we have. Okay, but as per syllabus we have only these two distributions we are going to learn, binomial distribution and Poisson distribution. Okay, so only these two distributions we are going to learn in this particular unit. And third unit we will get these things, we will learn in third unit continuous theoretical distributions. In this, normal distribution, student distribution, chi-square, F distribution, and more are there, exponential distribution, and next gamma distributions, okay, and uniform distributions. Okay, like that so many distributions in continuous, in discrete also number of distributions. But as per syllabus here also you have three distributions, and those three distributions we learn in third unit. Okay, and now before going to exactly that, so first we are seeing basic definition of that. So discrete uniform distribution. So what is that meaning of this discrete uniform distribution? So in the name only itself, uniform. Okay, so uniform is nothing but what we can say that equal. So equal priority. So uniformly it is going. If you are taking in school level, you people wear uniform. Okay, right? You people call uniform. Why? Because in the entire school, the dress of what you will wear, that is common to everyone uniformly. Okay, so here we are constructing what discrete distribution. Already we said discrete distribution is nothing but what x values we require. It means random variables and corresponding probabilities we require, right? So x values for various values of x, we can say we can take that one x1, x2, x3, and so on xn, right? So different variables will different random variables will choose that one, and uniformly we are saying here. So discrete distribution is nothing but finding the values of x along with respect to probabilities, that is discrete distribution. But we are saying here that distribution is uniform. So simply we'll say that distributing uniformly for different values of x, that is discrete uniform distribution. So distribution is nothing but distributing, uniformly is nothing but equal, and discrete is nothing but different values of x. Okay, so it means that if you are taking 60 members in a class, if you are giving a chocolates or if you are giving anything uniformly, in the sense we have to give each and everyone having same priority, right? So generally if you are teaching a class means we give priority for each and every students equal. Okay. So here probability is nothing but simply what we are saying, that is common thing. So 1 by k, and this is also 1 by k, and this is also 1 by k. So for different values of x we are saying we are equally uniformly distributing. Okay. So x1 1 by k, and x2 also 1 by k, x3 1 by k, and so on, xn also 1 by k. That is simply we are saying here one notation. A random variable capital X has a discrete uniform distribution if and only if its probability distribution is given by P of x is equal to 1 by k for x is equal to x1, x2, x3 and so on xk. Okay. So here that one. So we constructed in a table notation. Okay. Next, Bernoulli's distribution. Next topic. Next one. So Bernoulli's distribution. Here it is a random variable. Generally, it takes, if you are taking any one life, it is having two things. One is success, and another one is failure. Here also same like as a random variable capital X, which takes two values 0 and 1 with the probability Q and P respectively. So here we are taking random variable X, and it is taking two values. What are those? 0 and 1. So why? Because generally we are saying probability is nothing but 0 to 1. So here for that 0 and 1. So by saying simply we can say that 0 is nothing but simply what we can say, that is failure, and 1 is nothing but number 1 position, that is representing as success, right? So with probability q and p respectively, that is simply what we are writing. Pq is equal p of x is equal to 0, and p is equal p of x is equal to 1, and relation between these two is nothing but simply what we can write, p plus q is equal to 1. So p plus q is equal to 1. Then q is equal to 1 minus p. That only here we wrote. So already said, a person who faces success as well as failure in his life, he will approaches to a top position, number 1 position. Okay. So always don't think about we need only success, we need only failure. Okay. So a person who faces both, okay, if you are taking any successful person, he always says that I did like that, I failed that time, so that's why. Okay. So like that. So in 10 in below 10th class also people learn different stories. Okay. So this is p plus q is equal to 1. You need to remember all these things. So called a Bernoulli's discrete random variable. It means simply what we are saying, that suppose here it is we are taking x values are what are those, 0 and 1, and what we are taking those probabilities, p is here it is q, and here it is p. Okay, discrete probability distribution table we constructed. X values along with that respect to probabilities. Okay, and a discrete probability distribution means we have the properties. What are those two properties? So probabilities must be greater than 0. Another one is sum of all the probabilities is equal to 1. So it means sum of what are the probabilities here? Q and P. Suppose that we are writing as here P plus Q is equal to 1. Okay, it satisfies. Why? Because this is a discrete probability distribution. Okay, if it is a continuous one, simply what we'll say, that integral minus infinity to infinity f of x dx is equal to 1. That one will say that, right? So integral minus infinity to infinity f of x dx is equal to 1. There it is. Total area under the curve is 1. This is a discrete one, that's why we are saying. So what we said here, it is in a bone notation. That one we wrote here in a symbolic one. X values as well as p values. Okay. Now, it's called a discrete, is said to be have a Bernoulli's distribution. This distribution simply we calling as a Bernoulli's distribution, and the property function of Bernoulli's distribution can be written as p power x q power n minus x. So here probability function. So what we said here it is finding the probability function, we are saying as distribution of discrete probability distribution. Here the function is p power x q power 1 minus x, and here it is p asterisk, and q is nothing but what, 1 minus p. Suppose that 1 minus p whole power x, and here it is q is representing failure and p representing success. Okay, so that only here we wrote, let the probability for success be p and the probability for failure be q. So this terminology you need to remember that. And next, q p plus q. Suppose the random variables are repeated n times under identical conditions. These are called Bernoullian trials. Okay, so that is only for one time. So if we are repeating that experiment under n identical conditions, okay, conditions are same, then we'll say that those trials are Bernoullian trials. And next, binomial distribution. So why it is calling bi? Bi is nothing but here it is. We are getting as two outcomes. What are those two outcomes? Here we are getting success and failures. In symbolic notation, we can say that P and Q. That's why we are right. We are saying there it is having bi. So binomial. Okay. So monomial is nothing but one. Binomial is nothing but two. Okay. So in 10th class members, people learned that one binomial theorem. So that is x plus y. So binomial theorem x plus y whole power n. So here it is two variables. Here it is two or distributed variables are nothing but here it is we are discussing p and q. So the binomial distribution can be described with the help of a function and is derived as follows. Okay. And next, let the number of trials be n. The trials be independent, that is success or failure. One trial does not affect the outcome of the other trial, obviously. Okay. So is there any difference for trial to trial? Okay. So first trial, second trial. So obviously there is no comparison. Okay. Like a simple example, writing regular exam and supply exam. Is there any common thing? So common thing in the sense, is it shows any effect on that? Okay. Some of the people may take seriously. Okay. Why when they get the result, after that it will goes again poor. Okay. So in the same way here it is one trial should not be effect on the another trial. So trial is nothing but here it is experiment. Writing an exam is also an experiment. Number of times or number of trials. Okay. Here it is n random variable representing the number of successes. So n is representing what? Representing number of successes, and probability of getting r successes and n minus r failures in n trials is the given. The probability function is p of r is equal to, or p of x is equal to r is equal ncr p power r p power n minus r. Here what we are saying, n is representing number of successes and p representing, already we know that, success, and q representing what we are saying, failures, and r representing here it is r successes. How many successes here? R successes, and here it is n minus r failures. Okay. So n minus r failures and r successes, and n representing number of successes. This probability function is properly known as binomial distribution. This probability function we are calling as binomial distribution. So this is Bernoullian trials, binomial distribution. Okay. And next, here it is already we said 0 success and 1 success, 2 success. We are representing in a probability function notation. So if it is 0 success is nothing but simply we'll say that q power n, and 1 success is nothing but so p power 1 q power n minus 1, and 2 successes is nothing but so here it is 2 successes p square and n minus 2 failures. Okay. Next, in the same way, r successes and n minus r failures. That is simply what we are writing, ncr p power r p power n minus r. That is simply we can write q plus p whole power n. So this is not a new one what you learned in your 10th class, binomial theorem. So q plus p whole power n is nothing but simply what we are writing formula, nc naught q power n, right? nc naught q power n, and next plus nc1 nc1 q power n minus 1 p. Okay. And next nc2 q power n minus 2 p square, n minus 2 p square. And next, in the same way, plus and so on, plus we can write ncn p power n q power n minus n. So that only here we are saying, see that nc naught is nothing but remember 1. Okay. Obviously ncn is also 1. And what we are saying here, q representing failures and p representing success. So for that, if we are writing q power n is nothing but all failures. All అనేది ఎన్నమ్మ here all is representing n. So n failures. So that only here zero success we are saying. Okay, all failure means is there any success? Nothing. So for that zero success is nothing but q power n. And next nc1 q power n minus 1 p. So it representing p power 1. It means one success and n minus 1 failures. That only for that here one success is representing this. And next in the same way two successes nc2 p square q power n minus 2. In the same way, R successes is nothing but this one, and N successes is nothing but finally NCN is 1. So, and in other words, we can say that this Q power N representing all failures and P power N representing all success. Okay, and next, see the definition of this one, including definitions also very important. So, define binomial distribution. A random variable capital X has a binomial distribution if it assumes only non-negative values, and its probability density function is given by p of x is equal to r is equal p of r is equal ncr p power r q power n minus r when it is up to n successes. Okay, so 0 1 2 3 and so on n, and rest of the thing 0 otherwise. Okay, for n successes we are writing this probability function is ncr p power r q power n minus r. Maybe in place of this one we can write x also. Okay, so r or x. So it means if we are writing x, simply we'll write it here. It is ncx p power x q power n minus x, and x is representing here. It is 0 1 2 3 and so on here. An alternative p of capital X is equal small x is equal p of x is equal p of x n p is equal ncx p power x q power n minus x, what we wrote there. Here it is like this also we can represent that binomial distribution. Here x is representing successes, and is representing already we know that number of trials, and p representing success. Okay, so and one more thing we can say that these are the two parameters of the binomial distribution. So what are the parameters of binomial distribution means n and p. Why? Because by knowing these two values we can get this entire one. Okay, why? Because if you know p, obviously we can get q. Okay, so this is definition of binomial distribution. Okay, and next, conditions of binomial distribution. For applying binomial distribution, is there any conditions? So trials are repeated under identical conditions for a fixed number of times. So here what we are choosing, that must be fixed one number of times, that is nothing but 100 or 200. Okay, 200 300. It means suppose here it is we are writing x plus y whole power 1000. So number of trials must be fixed one. Okay, 1000 or 100 or lakh. Okay, like that. So further trials are repeated under identical conditions. Conditions must be same, identical those conditions for a fixed number of trials. Okay. Next, for every experiment we get only two outcomes, right? So writing an exam is also experiment. Coming to college is experiment. Okay. So for human life is also an experiment, right? It is also having both cases, birth, death, right? So in the same way here it is two possible outcomes. So what are those? Success, failure. Okay, so everything in our day-to-day life, what we'll do that everything it is having two options, right? Success as well as failures. Okay, so coming to college is a success, and not coming to college is a failure. Writing exam and passing is success, and failure is failure. Okay, so coming you may come to college and not coming to college, everything. So like that day-to-day life, everything is it is having two options. One is success as well as failure. And next, the probability of success in each trial remains constant. So if you are getting a probability of that success, whatever the trials, number of trials, how many you do that, that must be constant. There is no change in that. Okay, suppose if you write an exam, you pass the exam, is it changes anything? Nothing. It will constant. Okay, so there is no change in that, right? So that is here, and does not change from trial to trial, that one. Okay, so trial to trial, there is no change in that. Okay, so the probability of success in each trial remains constant. So these are the conditions we can say that for applying binomial distributions. Okay, of course the trials are independent, it means it doesn't affect on one trial to another trial, already we discussed. And next, constants of the binomial distribution. Okay, so this is where R derive the mean of the binomial distribution or variance of the binomial distributions. All these things you people will get it. Okay, so first one, the binomial distribution is given by. So we are taking the definition of binomial distribution. P of R is equal NCR P power R Q power n minus R, where R is equal 0, 1, 2, 3, and so on n. It means 0 success and this one. And relation already we know that P plus Q is equal 1. Now we are going to calculate mean of what? Binomial distribution. But we are discussing this is discrete. Okay. So for that, what is the formula for mean in discrete random variables? Summation R P power P of R. Right? Summation R P of R. Of course, if people learned there, it is having summation X into P of X. So this one you learned in first unit when you solve the problems or everything. So summation X into P of X. Actually, summation Xi P of Xi. So where I is from 1 to n, 0 to n, like that. But here it is, we wrote in terms of R. If you want, you can write in terms of X also. Nothing will happen. Now, so here it is, what is meant by P of R. Already we chosen that probability function in binomial. P of R is equal to NCR P power R Q power n minus R. Now we are substituting different values in place of R. So first, if you substitute 0, so 0 into anything. So this total one 0 into anything is 0. So for that, the entire term first become 0, right? So 0 into NC naught is nothing but 1. Anything power 0 is 1 and Q power n minus 0. So for that, 0 into Q power n. And next, if you substitute 1 in place of 1, so R in place of R is 1. 1 into NCR, NC1, P power 1, Q power n minus 1. So just we substituted in place of RS, next 2. So 2 into, in place of R, NC2, P square, Q power n minus 2. And in the same way like that and so on, if you substitute n. So here it is n, and next we will get it as there it is having NCN. So NCN is nothing but, keep in mind NCN as well as NC naught, these two values is equal to 1. Okay, so NCN and NC naught is equal to 1. So here it is, NCN is nothing but 1, and here it is, in place of R we substituted n, so P power n, and next Q power n minus R. So it means n minus n. So n minus n is nothing but Q power 0, anything power 0 is also 1. Then what about remaining? Only P power n. That's why here we wrote P power n. And if you observe each and every term, this is cancelled 0, no need to see here. From here onwards, if you see that, first we expand this one, n p q power n minus 1. How we got this one? 1 into n. So nc1 is nothing but n. So 1 into n is n. And next p as this and q power n minus 1. Okay, that is clear. And next 2 as this. And next nc2. So this is the formula we are writing. ncr is nothing but n into n minus 1 by 2 factorial. Okay, so nc2 is nothing but n into n minus 1 by 2 factorial. And p square q power n minus 2 as this. And next, if it is, if you write third term, so what about third term? There it is 3 into nc3 pq q power n minus 3, right? Pq q power n minus 3. So this is another term. Okay, so that's why here we wrote 3 into, and nc3 is nothing but n into n minus 1 into n minus 2 by 3 factorial, and pq as this, and q power n minus 3, and last term as this. If you observe each and every term, here it is having np, and here also n, and p square is nothing but simply, how can I write? P into p. Next, here also n, and p cube is nothing but, how can I write? P into p square. And next here it is p power n. Can you write this one as p into p power n minus 1? So a power m into a power n, a power m plus n. Here it is 1. So 1 plus 1 cancel. What about remaining? P power n, right? Suppose if you write this one as p power 1 plus n minus 1. So here it is 1 1, both will cancel. What about remaining? P power n. So this is we can write. Now we are taking common term as np. So after taking common, this term eliminated common. Then what about remaining? Q power n minus 1. Here 2 as well as 2 both will cancel, and remaining here it is n into n we took common and p also we took common. What about remaining? N minus 1 into p into q power n minus 2. And next 3 factorial is nothing but, how can you write that one? 3 factorial is nothing but 3 into 2, so this is equal 6. So that is nothing but simply what we can write, 3 ones are and 3 twos are. So that's why here we wrote 2 and n into n we took common and p also we took common. What about remaining? N minus 1 n minus 2 p square q power n minus 3. And after taking pn as well as p, these two commons, these two terms we took common, and what about remaining? Only p power n minus 1. And now np into, so simply you can write this one as binomial formula. Okay, so here it is, already we know that. So what is the formula? We applied x plus y whole power n. So x plus y whole power n is nothing but simply what we can write, x nc naught, nc naught x power n y power n my x power, next nc1 x power n minus 1 y power 1, next nc2 x power n minus 2 y square, plus and so on. In the same way, if we are taking that ncn x power n minus n y power n, right? So this is the formula we are writing for binomial. Just to compare this one with this one. So in place of n, what we have? N minus 1 here we wrote. Okay. Same like this here it is or not. So here it is, in place of x what we have? Q. In place of y as p. Is the same, and in place of n as n minus 1. Okay, so just to compare that, here it is nc naught is nothing but 1, forget about that. And next here it is x power n, it means q power, in place of n what we have? N minus 1. Next nc1 is nothing but what? N. So here n minus 1 c1, so for that n minus c1. Next in place of x what we said? Q. So for that q power n minus 2. So it means in place of n we are writing as n minus 2. So this is equal, in place of n what we are writing? N minus 1. Already minus 1 is there. So for that what we will get? N minus 1 minus 1 is nothing but n minus 2. Right? So n minus 2. For that here we got n minus 2. Okay. Next in the same way, next one, n minus nc2. So already we wrote here, see, n into n minus 1, n minus 2 by 3 factorial. This is nc2. But here is in place of n what we have? N minus 1, right? So n minus 1 into n minus 1 minus 1. It means, so this one, n minus 1 c2 is nothing but, how can I write that one? N minus 1 c2 is nothing but n minus 1. Next n minus 1 minus 1 by 2 factorial. So 2 factorial is nothing but 2. So here n minus 1 as it is, right? And n minus 1 minus 1 minus 1 minus 1 2. So n minus 1 into n minus 2 by 2 factorial is nothing but 2. And in p square, in place of y as it is, and this one. And here it is only y power n. But n is nothing but n minus 1. So further. But by when you are using binomial distribution, what we are saying, p plus q is equal to 1. So for that, simply we can substitute here it is q plus p is equal to 1. So therefore mean of the binomial distribution is np. So that is simply what we can write, mu is equal np. So mean is representing as mu. So mean of a binomial distribution is mu is equal np. Okay, so this is the proof of mean. Next, variance, we'll see that variance of the binomial distribution. So what is the formula we are using for variance? E of x square minus e of x whole square, right? Same like as mean. So here it is, e of x square is nothing but x square into p of x. but here it is r we are using r square into p of r, and e of x is nothing but mu, so for that mu square. And p of r we already know that. So here it is we are doing only one simplification. What is that? We are adding r and subtracting r. So if you cancel these two, plus r minus r, are getting same this one or not? R square into p of r. So here simply for simplification, that's what we did. We added r and subtracted r. Now we are separating the terms. In these two terms, if you observe this one, r square plus r, means r is the common one or not? If you take r as common one, r into r square plus r into 1. So r into 1 is nothing but r. So r into r plus 1 we are writing from these two terms. That's why here we wrote this like this. And of course, these two terms will be common from this term and this term. Here it is in place of plus, we get it as minus. Okay, and plus r as it is into p of r minus mu square. And now we are going to simplify this one. So first we are multiplying p of r for this term and separating the terms. So r into r minus 1 into p of r plus summation r into p of r. Nothing we did, just we multiplied these terms into p of r and we separated. And now we are substituting in place of p of r is nothing but ncr p power r q power n minus r. Okay, so here it is. This summation is valid only from r is equal 1 to n, not for 0. Why? Because here it is r minus 1 term. We already know that this is valid only for positive terms. So for that summation r is equal 1 to n, r into r minus 1, ncr p of r is nothing but ncr p power r q power n minus r. And this is as it is we wrote here, and here also mu square. Okay. Next we substituted different values in place of r. If you substitute 1, so here it is 1 minus 1. So 1 minus 1 is nothing but 0. So nothing to substitute. So next r is equal to 2. So for that 2 into, here 2 minus 1 is nothing but 1. So 2 into 1 nc2 p square q power n minus 2. Next we are substituting in place of r as 3. So if you substitute r in place of r as 3, and 3 minus 1 is nothing but 2, and c3 p cube q power n minus 3. So just what we did, in place of r we substituted 3. And finally if you are substituting last term in place of r as n, so n into n minus 1 into ncn, we'll get it as ncn. So ncn is nothing but 1. So for that we didn't write. And p power n, that's why here we wrote as this, and q power n minus n. So q power n minus n. So here it is n and both will cancel, q power 0 is equal to 1. Okay, so for that here we wrote like this. So 2 into nc2 p square, just what we did, we substituted different values in place of r. And now we are going to simplify this one, and here it is 2 into, so we are substituting the formula. Here it is n into nc2 is nothing but n into n minus 1 by 2 factorial. This is the formula we applied, and remaining as it is. And in place of nc3 is nothing but n into n minus 1 n minus 2 by 3 factorial. 3 factorial is nothing but how much? 6. And here 2 factorial is nothing but 2. And next here is n into n minus 1 p power n. Here it is, if you observe this one, 2 to both will cancel, and 3 into 2 6, here 6 and 6 also cancel. And what about remaining? N into n minus 1 p square q power n minus 2, n into n minus 1 n minus 2 p cube q power n minus 3. So p cube, how can you write this one? P square into p. Can you write that one or not? P square into p. Okay, so and in the same way p power n we can write it as p square into p power n minus 2, a power m into a power n, a power m plus n. If you write 2 minus 2 cancel, p power n as it is. Now if you observe this one, in each and every term n into n minus 1 is the common one. So that's why we took common here. N into n minus 1 p square is we took common. And what about remaining? This one we took common up to this one. And what about remaining? Only this is the term. So for that q power n minus 2. And here it is, this is common and this is V2 common and this is also V2 common. Okay, and what about remaining? N minus 2 here and if P here, Q power N minus 3. So N minus 2 P Q power N minus 3. And in the same way, if you write next term, we get like this. And here also, we took this one common and this is also common. In that, this is also common. What about remaining? Only P power N minus 2. That's why here we wrote like this. Plus mu minus mu square. And next one, we are taking that common n into n minus 1 into p square, same like as previous one. We wrote binomial expansion, q plus p whole power n minus 2. This total expansion we wrote. And now plus mu minus mu square. But if we observe this, this is in terms of n and p. So for that mean already we know that mu is equal to how much? Np. So that one we can substitute here and we can simplify. So n into n minus 1 into p square, q plus p is equal to 1. So 1 for n minus 2 plus mu. Mu is equal to np minus mu square. So np whole square. So now we are simplifying that n into n is nothing but n square into p square minus n into p square plus np minus n square p square. Here it is n square p square, n square p square both will cancel. And what about remaining? Np minus np square is the common one. So this is the common term. And in these two, which one is the common one? If you observe this one, np is the common one, right? So we can take that one as common. What about remaining? Here it is, if we take that one as common, 1 minus p, right? So np into 1, np minus np into p, p square. So np into 1 minus p is nothing but simply what we can write? Q. So q is equal to 1 minus p. Why? Because we already know that p plus q is equal to how much? 1, right? So for that q is equal to 1 minus p. So q is equal to 1 minus p. Okay. So now variance v of x is equal to np q. So that one we substituted here. Okay. So here it is, mean we calculated and variance also we calculated. Mean mu is equal to np and variance is equal to that. And next, standard deviation of the binomial distribution. So variance we are giving representation as sigma square, right? Sigma square is equal to npq. So this is we are giving as variance. And next, standard deviation is nothing but sigma. So sigma is equal positive square root of variance. So sigma is equal to square root of p and pq. So this is standard deviation. And next, mode of the binomial distribution. Already we got it this one. What is the meaning of that? It takes a value of x at which p of x has maximum. At which value of x the probability function is maximum, that value we are calling as a mode. Okay, here directly they give. So mode is nothing but what we have to calculate, n plus 1 into p we have to calculate. After finding that, if we are getting as an integer, okay, if you are getting as an integer, then the mode of the binomial distribution is this one, n plus 1 into p and n plus 1 into p minus 1. Okay, so this is the mode. When it is, first you need to know the value of n and p we need to know that. We have to substitute the n in value here. After substituting, if you are getting an integer, then we'll say that this is mode. If not, if you are not getting an integer, it means like as 2.3 decimal, okay, 2.3, 5.6, like this if we are getting after finding. Then we have to choose only integral part of this one. So this is we call as an integral part and this is we call as decimal part. Okay. In that case, the mode is nothing but just we have to take only integral part. Okay, we should not take decimal part. Okay. So for that, this is mode of the binomial distribution. Next, recurrence relation for the binomial distribution. We already know that P of R. So before that, what is meant by recurrence relation means? So recurrence relation is a relation which is useful to find for higher values, for different values of R. Okay. So like that, suppose we can calculate P of R, P of 1, P of 2, we know that. By taking those values, we can calculate the number of values. Okay. That's why we call this is recurrence relation for the binomial distribution. By using this, we can calculate number of values. So we already know that binomial distribution P of R is equal NCR P for R Q for n minus R, and P of R plus 1 is equal nothing but what we are doing, in place of R we are substituting R plus 1, then it changes to NCR plus 1 P for R plus 1, and here it is, in place of R what we are substituting R plus 1, so n minus of R plus 1, right, n minus of R plus 1. So just simply what we can write, n minus R minus 1. By multiplying minus inside of the terms, we are getting as this. Okay. Now we are dividing these two equations. P of R plus 1 by P of R is equal. Just we left hand side and right hand side. And next we took common these terms and we cancel this. So how we got this one? NCR plus 1 we can write as NC. So this is, we can write n factorial by n minus r factorial is nothing but n minus r minus 1 factorial. And next here it is, we can write r plus 1 factorial. So this is NCR plus 1. So r plus 1 factorial by NCR is nothing but n factorial by r factorial n minus r factorial. So this is simply we write n minus r factorial. So here it is n factorial and n factorial both will cancel. And r plus 1 factorial is nothing but how can you write this one? R plus 1 into r factorial we can write. R plus 1 factorial we can write as r plus 1 into r factorial. Here these two cancel. And next n minus r minus 1 factorial. That is also how can you write that one? N minus r minus 1, not this. So this is simply we can write n minus r factorial is nothing but n minus r into n minus r minus 1 factorial. Like this we can write. So this one and this one cancel. And now whatever remaining, this one goes to numerator and this one comes to denominator. So that's why here we wrote n minus r by r plus 1. And next here it is p power r plus 1 by p power r. That is by using a power m into a power n. Simply we can write p power r into p by p power r. So this p power r, p power r cancel, p remaining. So for that p here it is. And next this is also q power n minus r into, so simply what we can write, q power minus 1 by q power n minus r. Like this we can write this one and this one cancel. Q power minus 1 is nothing but how can I write 1 by q. So 1 by q. So that's it. And next we took this p of r into this side. So therefore p of r plus 1 is equal n minus r into p by r plus 1 into q into p of r. So this is the relation we will use for calculating higher values. It means if you know that p of 0, we can get p of 1, p of 2, p of 3, p of 4 by substituting different values in place of r. Okay, so this is recurrence relation of for the binomial distribution. Recurrence relation for the binomial distribution. So next we are going to see that problems on binomial distribution. Here what we learned that one from starting, what is meant by discrete probability distribution and what is meant by Bernoulli trial and what are the conditions are required for applying binomial distribution, and how to find mean and variance and standard deviations for binomial distributions, and also we learned recurrence relation for binomial distribution. Okay, now we are going to see the problems on binomial distributions.